Hello student, now we will discuss ray optics, refraction, laws of refraction in vector form. Now refraction, when light or wave strike the surface which separates two medium, then a part of it return back like bouncing of ball and remaining part enter into second medium such that frequency remains same but wavelength gets changed. So this phenomena by which light enter into second medium when incident on surface separating two medium such that its frequency remains same but wavelength gets changed is called refraction of light. Suppose AB the surface separating two medium, rare medium and denser medium, and suppose this is the normal on the surface N dash. Suppose from point P a light incident on the surface, the incident ray which incident on the surface at point O through which normal is passing and makes an angle with the normal I, the angle of incident. And suppose OQ is the refracted ray of light making an angle with the normal R, the angle of refraction. It bends toward the normal because light is moving from rare medium to denser medium. Now when ray of light enter from rare medium to denser medium, then wavelength and hence velocity of light decreases and vice versa. Due to this, the ray of light bends toward the normal when it incident from rare to denser medium and vice versa. That is, when it moves from denser to rare medium, it bends away from the normal. Now laws of refraction or Snell's law. Suppose AB is the surface separating two medium, rare medium and denser medium. A is rare medium and B is denser medium. From point P, the ray of light incident on the surface at point O is the incident ray of light. From point O, draw a normal N dash passing through point O. It is normal to the surface separating two medium. And incident ray of light makes an angle I with the normal called angle of incident. Suppose this is the refracted ray of light OQ making an angle R with the normal called angle of refraction. Now first law, it states that the ratio of sine of angle of incident I to the sine of angle of refraction R is always constant for given pair of medium and for light of given color or for light of given wavelength. That is, sine I upon sine R is equal to constant, or sine I upon sine R is equal to A mu B, which is constant and is called refractive index of medium B with respect to medium A, where I is the angle of incident and R is the angle of refraction. The A mu B constant is called refractive index of medium B with respect to medium A. Now second law, it states that incident ray, refracted ray and normal all lies in the same plane. This is the second law of refraction or Snell's law. Now laws of refraction or Snell's law in vector form. Let xx dash be the surface separating two medium. This is the xx dash surface separating two medium, rare medium and denser medium. And this is the normal to this surface, and MO vector is equal to ON vector is equal to n cap unit vector. Is the unit vector normal to the surface separating two medium. That is, MO vector is equal to n cap unit vector and ON vector is equal to n cap unit vector normal to the surface separating two medium or along the normal to the surface separating two medium. Suppose PO is the incident ray of light making an angle I in the rare medium. This is point P, and PO is the incident ray of light making an angle I with the normal, the angle of incident, and OQ is the refracted ray of light making an angle R in the denser medium. The refracted ray of light making an angle R in the denser medium. From point N and M, draw perpendicular to the normal to the surface separating two medium, which meets the incident ray and refracted ray at A and B respectively. This is the perpendicular from M meets the refracted ray at point B, and this is the perpendicular from N meets the incident ray at point A. If I cap and R cap are the unit vectors along direction of incident ray and refracted ray respectively, then AO vector is equal to magnitude AO into I cap, and OB vector is equal to OB magnitude into R cap. Now using triangle's law of vector addition in triangle OAN. This is triangle OAN. The vector AN, this is vector AN, is equal to vector AO plus vector ON. This is according to triangle law of vector addition. Or AN vector is equal to AOI cap plus N cap, because ON vector is N cap and AO is equal to AO vector is equal to magnitude AO into I cap. Put this equation number 1. And in triangle OBM, this is triangle OBM vector MB, this is vector MB, is equal to vector MO plus vector OB, or MB vector is equal to N cap plus OB into R cap, because MO vector is N cap unit vector and OB vector is equal to magnitude OB into unit vector R cap. Put this equation number 2. Now as AN parallel to MB, these are parallel, that is AN parallel to MB. Therefore, MB vector upon magnitude MB mean unit vector along MB is equal to AN vector upon AN magnitude, that is unit vector along AN. They must be equal. Therefore, MB vector upon MB is equal to AN vector upon AN. Now, MB vector is equal to N cap plus OB into R cap from equation number 2, and AN vector is equal to AO into I cap plus N cap from equation number 1. Put this equation number 3. Now, because in triangle OBM, this is again triangle OBM, MB upon OB is equal to sin R, because perpendicular upon hypotenuse is equal to sin R, implies MB is equal to OB into sin R. And in triangle OAN, this is triangle OAN, AN upon AO is equal to sin I, implies AN is equal to AO into sin I. So put these values, equation number 3. Therefore, from equation 3, we get N cap plus OB into R cap upon OB sin R is equal to AO into I cap plus N cap upon AO into sin I. Take sin I to the left hand side, or rearranging, we get sin I upon sin R into within the bracket N cap plus OB into R cap upon OB is equal to AO into I cap plus N cap upon AO. Or because sin I upon sin R is equal to mu, the refractive index of denser medium with respect to rare medium, and into within the bracket N cap plus OBR cap upon OB is equal to AO into I cap plus N cap upon AO. Because sin I upon sin R is equal to mu, the refractive index of denser medium with respect to rare medium. Or by rearranging, we get mu into within the bracket 1 upon OB into N cap plus OB into R cap upon OB is equal to AO into I cap upon AO plus 1 upon AO into N cap. Now OB and OB cancel each other, and also AO and AO cancel each other. Therefore, we get mu into 1 upon OB into N cap plus R cap is equal to I cap plus 1 upon AO into N cap. So put this equation number 4. Now in triangle OAN, this is again triangle OAN, On upon OA is equal to cos I. Base upon hypotenuse is equal to cos. Therefore, On upon OA is equal to cos I, or 1 upon OA is equal to cos I, because On is equal to n cap unit vector. Therefore, magnitude On is equal to 1, because On vector is equal to n cap is unit vector. Therefore, On magnitude is equal to magnitude of On vector is equal to 1. Similarly, in triangle OBM, this is triangle OBM. OM upon OB, base upon hypotenuse, is equal to cos R, or 1 upon OB is equal to cos R. Again, because OM vector is equal to n cap unit vector is unit vector. Therefore, OM magnitude is equal to magnitude of vector OM is equal to 1, because magnitude of unit vector is 1. Putting these values in equation 4, so we get mu into cos R into n cap plus R cap is equal to I plus cos I into n cap. Open the bracket in left hand side. Mu into cos R into n cap plus mu into R cap is equal to I cap plus cos I into n cap. So taking the mu into cos R into n cap to the left hand side, so we get mu into R cap is equal to I cap plus cos I into n cap minus mu cos R into n cap. In the right hand side, from last two terms, take n cap common, so we get mu into R cap is equal to I cap plus within the bracket cos I minus mu cos R into n cap, or R cap is equal to 1 upon mu into within the bracket I cap plus within the small bracket cos I minus mu into under root cos square R, because square and under root cancel each other, so we can write cos R as under root cos square R into n cap, or R cap is equal to 1 upon mu into within square bracket I cap plus within small bracket cos I minus mu into under root 1 minus sin square R into n cap. Put this question number 5, because sin square theta plus cos square theta is equal to 1. Therefore, we can write cos square R is equal to 1 minus sin square R. If mu is the refractive index of tensor medium with respect to rare medium, then sin I upon sin R is equal to mu, implies mu into sin R is equal to sin I, or sin R is equal to sin I upon mu. So put this value in equation number 5. We get R cap is equal to 1 upon mu within square bracket I cap plus within the small bracket cos I minus mu into under root 1 minus sin square I upon mu square into n cap. Now within the square root, take LCM. So we get R cap is equal to 1 upon mu into within the square bracket I cap plus within small bracket cos I minus mu into under root mu square minus sin square I upon mu square, and outside the small bracket n cap unit vector, or implies r cap is equal to 1 upon mu into within the square bracket I cap plus within the small bracket cos I minus mu into under root mu square minus sin square I upon under root mu square into outside the small bracket n cap unit vector. Now square root and square cancel each other, so we can write I cap is equal to 1 upon mu into within the square bracket I cap plus within the small bracket cos I minus under root mu square minus sin square I upon mu into outside the small bracket n cap unit vector. Now mu and mu cancel each other, therefore we get r cap is equal to 1 upon mu into within the square bracket I cap plus within the small bracket cos I minus under root mu square minus sin square I into outside the small bracket n cap unit vector. Put this question number 6. So this is the law of refraction in vector form. That is, if we are given I cap, the unit vector along the incident ray, and n cap, the unit vector along the normal at the point of incident, we can find the unit vector along the refracted ray of light, that is along OQ. Mean we can find the refracted ray of light from this equation if we are given the incident direction and normal direction. So in this vector form, we can find the direction of refracted ray of light for any given incident ray of light and normal to the surface separating two medium. So this is the law of reflection, law of refraction in vector form. Thank you very much.